Okay, now we start to describe the so-called thermal diffusion, diffusion thermal instability, and look at the similar structure we may have uh, in the right figures. As we described before, for the lambda instability, we start to think about we have originally we have originally a flat flange, and we try to give a disturbance to make the flange has some curvature occurs. Okay, and look at the right figure here. Originally, you may think this is a blue flange. Okay, our reaction zones, and you can think originally there is a flat roof line exists here. Now we have a disturbance, and this disturbance will give you some curvature on the frame surface, right? Okay. But in this part, we need to think about the influence coming from the preheating zone. We cannot collapse the preheating zone with the reaction zone. Now there is the other line, the broken lines represent the boundary of your preheating zone. Okay, you remember it. Then the region between the broken line and the blue color line represent the preheating zone. Okay, now think about problem like this. The frame shape, the premise frame separate your flow as in the lower part. We will think about this as the upstream of your premise frame, and the upper part represent the downstream of your premise frame. That means that we supply the upstream premixture from the lower part, and after chemical reaction, after the burning, then the product will move to the downstream part, to the upper part. Okay. Now think about when you have a disturbance and your frame shape come curved like this. You can see now our frame. For example, now you need to separate to discuss the two parts. Okay, let's look at that part. You can see now your frame, based on our outer perturbation, the frame shape convex to the downstream part. Okay, when you have a frame convex to the downstream region, now you will find out this is just like a mirror. And when you look at the diffusion process in the preheating zone, you will figure out the diffusion heat will diffuse from the high temperature zone to the low temperature zone, right? That means from the blue flame to the broken line, the preheating zone. Now, when you think about those kinds of direction of heat diffusion, and indicated by the red color arrow, then you can see the heat actually is the more has some focusing effect, right? When you have focusing effect, that means that you will bring originally the smaller energies distributed in a large area, then they will bring to to a small area. That means that you will make the energy density become larger in the upstream side, right? Okay, from the largest space, larger surface to the small surface, then energy is concentrated, which means that in this case, energy has a so-called, the heat has a focusing effect. But for the mass, this has a reverse effect, right? Because for the for the mass diffusion, they will diffuse the mass from the edge of your preheating zone to the flame zone. Then the arrow show you the green arrow show you actually this effect is some kinds of defocusing. Okay, that the mass distributed in a small region will be redistributed to a large region. Then your mass densities for a given control volume will be reduced. By this kinds of reducing the mass concentration in a given surface, actually this will give us a so-called a defocusing effect. Basically, you will figure out this will show you a negative effect, but for the heat diffusion, there will a positive effect. Okay. Now, if you look at the structures for the right-hand side, now the flame is convex to the upstream side. then you may experience the complete opposite influence for the heat diffusion and the mass diffusion. Now the heat diffusion has a defocusing effect, but mass diffusion has a focusing effect. Now, if you understand those kinds of influence coming from the flow curvature on the diffusion process, then we will think about how to balance these two diffusion transport, heat and mass. Always, we need to give you some memory on the definition of Lewis number. Lewis number is equal to the heat diffusibility with balance with the mass diffusibility. Okay, and Lewis number equal to 1. That means that both diffusibility are similar. The strengths for them are the same. But if Lewis number bigger than 1, you need to think about the heat diffusion is stronger than the mass. Okay. And conversely, Lewis number smaller than 1, then the mass will be stronger than the heat. Okay, now let's look at the first case. If you think about the Lewis number bigger than 1, Lewis number bigger than 1 means the heat is stronger. Okay, heat diffusion transport is stronger than the mass diffusion transport. Now, what happened? We need to think about from the figure. Okay, the first part, you understand heat influence, the influence coming from the heat diffusion is stronger than that coming from the mass. Okay, for both the left friend and the right friend, both of them has some curvature. But for the left hand side, the curvature has convex to the downstream side. But for the right one, the friend shape has a curvature and convex to the upstream sides. Okay. But anyway, now when you look at this premixture, they should have the same Lewis number, which means they tell you the heat diffusion stronger than mass diffusion for both two curved frames in the left hand side and also in the right hand side. Okay. Now look at the left hand side at first. Now heat diffusion stronger than mass diffusion in this case because the heat has a focusing effect. Is the positive influence, right? And the focusing effect will corresponding to the mass diffusion. Usually they will give you a negative effect, which means in this case, in the left-hand side, the positive effect is stronger than the negative effect. That means that you will have a more heat to support, to preheat the coming premixtures, then the burning strength will become stronger. Now, if you have a stronger burning intensity, that means the flame speed become higher, then the flame will shift, will move to the upstream. Okay. Then you look at the left flame. Originally, they have a convex to the downstream side, right? But when you have the Lewis number influence coming from in the preheating zone, you will see flame become stronger. This flame will move to the upstream. You have a curvature originally, but the diffusion transport will give you a possibility to go back because the flame becomes stronger, then the flame will move to the upstream side and has a strong possibility to go back to the original position, becomes a flat. Okay, this is a first part. Then the flame can go back to the original flat flame. That means that this flame is stable flame, right? They can come back. Okay, but for the right hand side, you will find out still we have because we are talking about the same premixture, right? Heat diffusion for the Lewis number bigger than 1 still stronger than the mass diffusion. But in the right hand side, you understand heat has a defocusing effect and show you a negative influence on your burning intensity. Okay, and since we have a Lewis number larger than 1, the negative influence is stronger than the positive influence. That means that your flame become weaker. When you have a weaker flame speed smaller than the coming premixture, this flame will shift to the downstream side, right? They will shift to the downstream side. In this case, originally the disturbance, the perturbation will give you a curvature of your premixed flame convex to your upstream parts. But now this flame will move to the downstream side, which means they will go back to the original position to remain the flat flame. The dead flame the left friend, they will move forward, but the right friend will move to the downstream side. The left hand side forward, the right hand side backward. Then they will give you. There is the possibility to give you a chance. The previous friend will move back to the original flat friend. Now you can justify this Lewis number larger than one frame will be so-called the stable. Okay, in this sense, you have a original flat frame. Now you give outer perturbations, then frame become curvature, and when you release the outer perturbation, suddenly then you will find out the curvature, the curve frames will go back to the original flat frame shape. Okay, now we can conclude actually for many premise frames stabilized in laboratory, actually they show you there is a stable frame. They can endure the outer perturbation. They will not move to the different states by influence from the perturbation. The Lewis number bigger than one has a stability to let your frame stabilize in a given positions. Okay, this is the first part. Now we move to the other category. If Lewis number smaller than one, what do we do? Okay. Oh, there is a arrow to tell you the left frame will move to the upstream side, but the right frame will move to the downstream side. By this balance, the frame will go back to their flat shape, a planar shape. Okay. Now, okay, look at the other part. We look at the Lewis number smaller than one, which means we may have a conclusion on the unstable as unstable frames. Okay, similar way you can understand based on the Lewis number smaller than one means Lewis number smaller than one, the mass diffusion transport stronger than the heat for the left hand side and for the right hand side. Okay, but they show you have a different kinds of influence for the left hand side here. Similar way, when we discussed with the previous one, the focusing effect, the heat focusing effect, basically they give you the positive influence, but the mass has a defocusing effect, give you the negative effect. But unfortunately, for Lewis number smaller than one, okay, means the negative effects in this case is stronger. Stronger means the burning intensity is weaker, frame speed smaller. When you have a small curvature occur, by the influence of outer perturbations, you have a small curvature. But now, when you have this small curvature will induce a negative effect, frame becomes weaker, then this curvature will become larger. When you have a larger curvature, means that this frame will move to the downstream more. Okay, this curve frame will move to the downstream has a larger curvature, become more severe. Okay, and the right hand side tell you heat diffusion smaller than the mass diffusion. The defocusing effect is a smaller, and the negative effect is sure is a smaller. Then your burning intensity will become stronger. For the right hand side, the frame becomes stronger. That means the frame velocity, frame speed is larger. Then this frame will move to the upstream side, and you can think about the whole frames. The left hand side will move further downstream. The right hand side will move further to the upstream side. By this kinds of movements, the curvature of your perturbed frame will become severe, right? And they do not have a chance to go back to have a flat frame. By this kinds of analysis, you can conclude basically from the balance between the heat and mass diffusions. Definitely this frame cannot go back to the original state. Then we call these frames are unstable. Okay, and basically Lewis number smaller than one in general for many kinds of hydrocarbon frames, they will show you the so-called unstable frame structures. I will give you some experimental observation to let you know about the inference coming from the Lewis number. This is a typical one, very nice experiment. Actually, they did this experiment very earlier in 1949, published by Maxton. Okay. And this experiment is a quite simple experiment, and they study the butane, okay, the butane, oxygen, and the nitrogen mixture. They try to mix different kinds of concentration, but basically the fuel is the butane, and they keep the equilibrium ratio as around 1.35. That means a rich premixture. Now we go back a little bit. As you remember, we try to analyze to estimate the Lewis number for given hydrocarbon premixture, right? And we usually have a conclusion for rich hydrocarbon air nitrogen friends or rich hydrogen air mixtures. For example, we are dealing propane premixed blend, rich propane premixed blend. We estimate its Lewis number should be smaller than 1. Okay, and this case is good for us to identify the instability of such a friends. In this case, Lewis number smaller than 1. I hope you remember Lewis number smaller than 1. The group for the Lewis number smaller than 1 friend belong to the unstable friends. Okay, we want to see what kinds of friend structure we may have. From the experiment, you can experience there's very interesting friends because originally because they try to use they use the glass tube to have a jet frame, but they used some stabilization techniques to stabilize a flat frame. Usually, when you have a stable burning, then the flat frame will give you the planar frame shape. Okay, but in this case, because they use the butane and the rich, and we are looking at the rich hydrocarbon air premixed strands. And in this case, Lewis number more than 1, and they try to change different kinds of the pressure, and you will find out actually the pressure do not have too much influence on the flame shape, and all flames show in these figures from the paper. They show you there is some cellular structure. Okay, this is one of the cellular structure friends you may see, and this is a typical example for the unstable premixed frame. Okay, originally they have a flat frame, but in this case, because they moved to the other stage to have a different kinds of structure, and those kinds of frame instability. The first one I gave you the idea. This is so-called the cellular frames. Cellular frame just like a honeycomb. They have a small so many small frame curvature has some curvature, and they group together, and this is a typical observation from the experiments. Okay, now later on I will give you some strip frames and some situation for the polyhedral frames. The next experiment actually published by our research group. Okay, at that time, we tried to study the frame interaction, parallel interactions. We suppose there is the two frames and they sit at different positions. One maybe a little bit at this position, the other one is a lower position, and we want to see the interaction between these two frames. And we use the coaxial jet impinging on the stagnation point flow. Coaxial jet, you can see the inner tube and outer tube separately be supplied different mixtures. Okay, and we use propane as the test fuel in this experiment. I will explain a little bit to those very nice French chef for you. And maybe we can look at from this one. Or I need to mention here, there is the condition I specify. Omega O represent the mixing ratio in the outer tube. Okay, and omega I represent the mixing ratio in the inner tube. Okay, the first case for the propane, 2.8 and 2.8 both has 2.8% propane in the inner tube and the outer tube. Actually, 2.8 represents the leakage, lean propane. The stoichiometry ratio for the propane is around 4.5 something, near very close to the 4. Okay. Now, if you think about the concentrate omega is 2.8, that means that you have the identical concentration or mixing ratio for the inner tube and the outer tube, then you will have a nice premixed frame. Okay, this is a flat and a planar premixed frame. Okay. Now in the right hand side, we try to fix the concentration here in the outer tube as a lean case. Okay, 2.8, 2.8, 2.8, 2.8. But we continue increase the concentration of the inner tube from the lean and approaching to the rich side. Okay. Now you can see when you increase the concentration to we're looking at the concentration change in the inner tube. The concentration of propane starting from the lean 2.8 increased to the 4.5. 4.5 is a slightly higher, very closer to the rich parts. Okay, the slightly rich. Then you can see here. Okay, there is a because the inner tube is a richer part. They start to have this the richer frame. Actually here this is a richer frame and this is an outer dim frame. Okay, and a richer frame 4.8 because the concentration is very close to the stoichiometry, has a strong burning, and this frame will sit closer to the burner exit. Okay, and since 4.5 is slightly richer, they have some fuel left in the downstream. They will burn additional oxygen coming from the outer jet, and this will be the diffusion frame. Okay, I repeat again. I hope you understand the whole structure. Originally, for both of the inner jet and the outer jet, they have the same propane concentration 2.8 and 2.8. Both of them are lean premixed frame. Okay, then you will premixed frame stabilize in certain positions. But now you try to increase your lean mixtures to closer to across the stoichiometry ratio around 4.0, 4.0. Then they move to the slightly rich. But for the slightly rich case, since you have a stronger burning velocity than the flame position originally from 2.8 somewhere here, then they will move to the downstream to the upstream side, closer to the premixed to the exit plane of your burner. Okay, and since 4.5 is larger than the stoichiometry ratio, you have some excess fuel left in the downstream side. They will burn the extra oxygen in the downstream of the outer jet. Then you have a broad burning zone. This represents diffusion frame. Okay. If you increase the mixing ratio even richer to 4.5, from 4.5 to 5.8, then you will see because the frame is a richer, frame velocity, frame speed smaller, then this frame will move to the downstream back. Originally, they will sit very closer to the burner exit plane, but now for the propane mixtures as 5.8, the frame will move to the downstream side. Okay, and when this frame move to the downstream, you will have a very interesting observation, right? And you will find out there is the look at just like a pudding shape frame exists in the inner jet. Okay, and then you can see there is the so-called strip frame. As I mentioned, this kind of frame shape represents unstable frame because you now in the Lewis number smaller than 1 conditions. Okay, and here this is a rich frame, so therefore you will have an extra fuel depth combined with the original oxygen depth in the inner jet. Then you can see this diffusion frame is more clear. Okay. Increase your concentration of your propane in the inner jet from the 5.8 to 6.3. That means that your frame becomes weaker more and smaller frame speed. And finally, this frame will attach to the stagnation plane, the quartz plate, and a big extension. Therefore, you can see the inner frames exist as a plane shape. Okay. and basically they will be stabilized based on the diffusion frame. Here you can see we call this a so-called triple frame. The lower one represent the inner the DIN premixed frame, propane premixed frame, and it is the corresponding to 0.8, right? And here the vertical along the vertical axis, the curved frame represent a rich propane frame, and the concentration is around 6.3, and both of them have extra reactants that in the downstream, for example, for the inner jet, they have extra oxygens, and for the rich premixed frame, they have extra fuel, and they will meet together along the interface of the inner and outer jets, and the diffusion frame will stabilize here. This is a lean premixed frame and a diffusion frame, and the inner frame is a rich premixed frame. Okay. And the other case, maybe we move to the left-hand side. And the first figure tell you, actually, we do not have any propane induced into the outer jet. We just have a rich premixed frame exists here. Then you can see similar way as the previous example. You have a premixed frame, a rich premixed frame sit closer to the exit planes, and the extra fuel will burn with the outer oxygen coming from the air. Okay, the outer flow basically is the pure air. Okay, but if you try to increase your propane mixture as rich as possible, you can see similar to the previous case, you start to have a rich premixed frame exist, and those frame shape become has a strip frame shape. Okay, later on when you move to the 6.3, the planar frame closer to the stagnation plane, the course plane, then there will be extension. Okay, and we try to look at the other frame shape, and we already mentioned there is some for unstable premixed frame can be identified based on cellular frame structure like this, right? And now we give you some experimental observation on strip frames, and you still can see the so-called strip frames occurs on different way. For the inner frame, you can see those kinds of strip shape occurs around the cylindrical frame shape, right? And when you look at the other experimental system, you can see there is some strip frame occurs on the inner frame. As the inner frame increase the concentration from the 5 to the 5, you can see there is to the 5. 5 is the rich premixed frame. You can see there is some wavy or curve on the frame surface. Originally, for example, for the 2.8, you can see this is a very nice smooth frame, right? Even they have a curvature, but this basically is influenced by the original cold flow structures, because there is some mixing between the inner jet and outer jet. But when you see the curve shape in the other set experiment as we specify, the concentration of your propane in outer jet, you will see for the 5% propane, actually you can see some wavy on the frame shape in the outer jet, just like the pipe. When you have an experience to eat the pipe, the shape has some wavy on the frame surface. And this is another typical observation on frame shape. Basically, we can refer to the so-called strip shape frame. And this strip shape frame occurs for the rich propane frame, which means it's a Lewis number smaller than 1 unstable frame. And those kinds of frame structure can be observed from a laboratory to tell you the influence coming from the balance between the heat and the mass diffusion, and the Lewis number effect will give you to identify there is a lot of many situations to have a stable frame, especially when you have a Lewis number larger than 1. Now the influence coming from the diffusion transport in the breathing zone will give you the idea, give you the support to then push your disturbed frame to back to the original one. But then still I have some unstable situation. For example, for the Lewis number smaller than 1, now you will find out that you may not have a flat frame, then the frame will have a different kinds of curvature on the frame surface.